Okay, everyone, Assalamu alaikum. Let's begin. So we were doing coordinate geometry. That's what we started in our last session. Today we will be doing some more concepts of coordinate geometry. So there were some basics that we did. Let me just remind you about what we did in the last session. We started with these basics: how to represent points on coordinate axes, how to find distance between 2 points, midpoint of 2 points, gradients. What we understood what the gradient, the number given by gradient, what that means. Then we talked about what a positive gradient line looks like, what a negative gradient line looks like, what a horizontal, what the gradient of a horizontal line is, what the gradient of a vertical line is. Parallel lines have same gradient. Perpendicular lines have gradients that are negative reciprocals of each other. Then we talked about equation of straight lines. There was one form that you had done before, y equals mx plus c. So what do you need for that? You need the gradient of the line and also the y-intercept to be able to write down the equation of the line in this form, y equals mx plus c. And then we did another form, which was y minus y1 equals m into x minus x1. Okay. This is the other form. This is called the gradient point form. We learned where this form comes from as well. But now you have to basically just remember this form. Just like you remember y equals mx plus c, you should also remember this form. This is much quicker to use in most situations. When you have gradient given and a point given, you can just input those values of gradient and the point in this form, and you get the equation of the line directly. Y minus y1 equals m into x minus x1. In this case, m again represents the gradient. X1, y1 are the coordinates of the point that lies on the line. All right, so this is what we did in our last session. We did some examples of this as well. We said y equals mx plus c is more efficient to use when you have the y-intercept given, and y minus y1 equals m into x minus x1 is more efficient to use when you have a point given. When you don't have the y-intercept given, when you have another point given apart from that. So when y-intercept is given, use y equals mx plus c. When y-intercept is not known, use y minus y1 equals m into x minus x1. Now today, again, we are going to do 3-4 new concepts because all of these are very straightforward concepts. So we're going to spend, we're not going to spend too much time on them. We'll do them quickly. So first of all, the first thing we want to talk about is how to solve simultaneous equations. Again, you've done this in paper 1, in O levels before as well. In fact, in quadratics as well, we have solved simultaneous equations. But let me just remind you of the different methods that you have to solve simultaneous equations. If you have an equation that looks like this, let me write them like this first. 2x plus 4y equals 10. And let's have another equation that's 3x minus 12y, that equals 15, or let's say 20. If I have these two equations and I want to solve them simultaneously, how would I go about doing this? Now, there are two ways of thinking about this. One way is elimination and the other is substitution. Okay. So how do we do it? Let's start with substitution first of all. One way of doing substitution is that we make one variable the subject in one of these equations. For example, if we look at the first equation, in fact, the first equation can actually be simplified to x plus 2y, that equals 5. Now you make any one of the variables the subject here. Generally, it's going to make things easier if you make that variable the subject that does not have any coefficient with it, as in that only has 1 as the coefficient. So in this case, the coefficient of x is 1. So it's going to make things easier if you make x the subject instead of making y the subject. Why? Because if you make y the subject, you would have a fraction. You'll have to divide by 2, and that will be that will make things more complicated to evaluate. If you make x the subject, you won't have any fraction. So that's going to make things easier for you. Put this in the other equation. In place of x, put 5 minus 2y. And what does that give you? Minus 12y equals 20. You solve this equation, that gives you 15 minus 6y minus 12y equals to 20. And then you have minus 18y equals 5. And y equals minus 5 over 18. That's the value of y that I'm getting. Put this back in the first equation. That gives us x equal to 5 minus 2 into minus 5 over 18. And that's going to be 5 plus 10 over 18. 5 plus 5 over 9. Someone tell me what that simplifies to? What do you get from this? Is it 50 over 9?
Yes, sir.
Okay, 50 over 9. X equals 50 over 9. Okay, so these are the values of x and y that we get from this. Now, generally, when you do this in the exam, you get some nicer looking values. Not always, but mostly you would get integers or maybe fractions like this, 1 over 2, 4 over 3. Not large fractions like this generally, but this is possible. This can also come. You have x value of 50.50 over 9 here, and the y value is minus 15 over 8. These are the two solutions of this equation. This is one way of solving this equation using substitution. Okay. Another way of doing substitution is, so this is one possibility of doing substitution. Another possible way of doing substitution is that you make the same variable the subject in both of them. We used to do this a lot in quadratics, that we would make y the subject in both equations, or maybe sometimes make x the subject in both equations and then equate them. That's also a kind of substitution. Let me do that in another set of equations. Let's say we have 2x plus y that equals 5, and we have another equation which is 4x minus 3y equals 10. Again, I've just written two random equations like this. One other way of doing substitution is you make the same variable the subject in both of them. So in the first one, for example, I could do 5 minus 2x, y equals 5 minus 2x. If I make y the subject in the second equation as well, that's going to give me 4x minus 10, that equals 3y. And then y equals 4x minus 10 over 3. So I've made y the subject in both of them. Now I could just equate them. 5 minus 2x equals 4x minus 10 whole divided by 3. That's another way of doing substitution. Why am I calling this substitution? Because essentially what you're doing is you're putting this y value, y equals 5 minus 2x, in the other equation in place of y. In place of y, you're inputting 5 minus 2x, and that gives you this equation. Right? So this is also a kind of substitution, when you make the same variable the subject in both equations and just equate them like this. Okay. Now you can solve this equation. Now 3 into 5 is 15. 15 minus 6x. On the other side, we've got 4x minus 10, and that gives us 10x equal to 25. And x turns out to be 25 over 10, which is 2.5. Or you can write it as 5 over 2. That's the value of x. Put this back in any one of those two equations, and that would give you the corresponding value for y. So in this case, y turns out to be 5 minus 2 into 5 over 2. Well, it turns out that y in this case is 0. So these are the solutions of these two equations. X equals 5 over 2 and 0. That's pretty good. That's another way of doing substitution. Okay, there's another method that's using elimination. For some reason, some people find that complicated, although that's much quicker in some cases. So if you want to use that, you can also do that. The idea of elimination is you make the coefficient of one of these two variables the same in both equations, either x or y. Make one coefficient the same, at least in terms of magnitude, as in it's possible that one of them is 3y, one of them is 3 and the other is minus 3. That's okay, as long as the magnitude is the same. So it should be 3, 3, for example. Or you can make it 4x and you have 4 here as well. Make one coefficient the same in both equations. So in this case, one possibility is that we multiply the first equation by 2, and that gives us 4x plus 2y equal to 10, right? And now we just write these equations like this: 4x plus 2y equals 10, and 4x minus 3y equals 10 as well. Now we do elimination. Elimination means you want to get rid of one of these variables. You want to eliminate one of these variables. You either want to eliminate x or y. Now, since the coefficients of x are both the same now, and they're both positive, what we can do is we can say, let's subtract the second equation from the first one. So let's call this the second equation. Let's call this the first, call these first and second equations. You can subtract the second one from the first one. How do you do that? You change the sign. This is minus, this is plus, this is minus, this gets cancelled. 2y plus 3y, what does that give you? That gives you 5y, that equals 0. The y value turns out to be 0 from this. Put this back in any one of those two equations. Let's say I put it in this one. That will give me 4x plus 2 times 0, that equals 10. And the value of x turns out to be 2.5 or 5/2. So these are the different methods that we have for solving equations simultaneously. We have two main categories: substitution or elimination. Now, elimination generally only works for linear equations. If both of those equations are linear, generally speaking, that's when you do elimination. Sometimes it could work for other equations as well, but that's only in some particular cases. Generally, it only works for linear equations. Substitution, on the other hand, is a more general method that works for any kinds of equations, right? So if you have to solve any equation simultaneously, and maybe one is linear and the other is not, maybe both are nonlinear, in those cases, substitution is going to be your go-to method. Okay, so if you know substitution, that will work for everything. Okay, if you don't know elimination, you can kind of get away with that. That's okay, because you can do everything using substitution as well, and that's going to work in all cases. So as long as you do, as long as you know substitution well, that is going to work for you. Okay, so now that we understand how to solve simultaneous equations, let's try to understand when we solve these simultaneous equations, the answers that we get. For example, in this case, we get x equals 5/2 and y equals 0. What do these answers represent? What is x equals 5/2? What is y equals 0? What do these represent as far as these equations are concerned? These values of x and y, these are actually the only values that satisfy both of these equations at the same time. So algebraically, what it means is these values of x and y, x equals 5/2 and y equals 0, these are the only values of x and y that would satisfy the first equation and the second equation at the same time. There are no other possible values of x and y that would satisfy both the equations. You do have some values of x and y that satisfy one equation and not the other. For instance, the first equation could be satisfied if you input x equal to 2 and y equal to 1. But these values do not satisfy the other one. Okay. Similarly, you could have one value like this: x equals 2 and y equals minus 2. That will satisfy this equation. But these values do not satisfy the first one. Okay. X equals 5/2 and y equals 0. These are the only two values that satisfy both these equations at the same time. Okay. That's what it means algebraically. Now it also has a meaning graphically, because these are straight lines. This is a straight line. This is a straight line. If you were to draw these on a graph like this, if you were to sketch these, this is y-axis, this is x-axis. The first one is a downward sloping line with gradient -2. We'll actually figure out how to find gradients next in a few minutes. But the first equation is going to look like this. It's going to be like this, and it's going to have a y-intercept of -5. The first one, sorry, +5. This is the first one. It's going to look something like that. And the second one, this is going to look like this. The second one is going to look like this. Okay, the second one is going to be something like this. However, since the point of intersection is not the same, this is -2 gradient. What about this gradient? This is 3/4. Okay, sorry about that. I think I should do that a bit more accurately, or let's do this instead. So this is 5. So that y-intercept is supposed to be 10/3, which is 0.33. Okay, that should work. The other equation looks like this actually. Yeah. So this is what the two equations look like. The second one is 4x minus 3y equals 10, and the first one is 2x plus y equals 5. Okay. These two equations intersect at some point. This is their point of intersection. This point of intersection is this 5/2 and 0. This is the point of intersection, 5/2 and 0. So graphically, this point that we have found, it represents the point of intersection of these two lines. And that's exactly why we can equate these two equations like this here. So remember what we did here? We said y equals this and y equals this, and then we equate them. Why do we equate them? We equate them because graphically, if we look at this point, at this point, the point where these two graphs intersect each other, these two lines are equal to each other. These two lines have the same value. This point is common between both of those lines. So at this point, both lines are equal. They have the same value. That is why we equate them like this. So equating them like this and solving simultaneous equations gives us point of intersection. That's what its graphical meaning is. Graphically, the solution that we get from simultaneous equation, that gives us the point of intersection of the two graphs. All right. Any problems with this? Any questions? So this is the point of intersection of the two lines. So whenever we solve two equations simultaneously, we get their points of intersection on the graph. Since these are straight lines, they only have one point of intersection. Okay. All right, let's move on. So you know this from O-levels as well, but just I had to give you a reminder about this. Now let's discuss the next thing. Finding gradient of a line from its equation. Now again, it's a pretty straightforward thing, but let's discuss this. Finding gradient of a line from its equation. This is the next thing that you need to know about. Let's say you have an equation that looks like this. Y equals minus 4x plus 7. What's the gradient of this line? How do you figure that out? You compare it with the standard form. What's the standard form? The standard form is y equals mx plus c. You compare it with that. If it's written in the standard form, whatever is the coefficient of x, you say that is your gradient. So in this case, you can see in place of m, you've got minus 4 in the equation. So what's the gradient? The gradient of this line, therefore, is minus 4. So if you have something in this standard form, this is how you would find the gradient of this line. But what if you had something written differently? If you had, for instance, 4x plus 5y equal to 7, if you had an equation in this form, what would be the gradient of this line? Take a minute, everyone, and write down the gradient of this line. Tell me the gradient of this line in the chart box quickly. What do you get? What's the gradient of this line? Can all of you respond? Okay, great. So 4x plus 5y equals 7. How do you find the gradient of this line? The first thing you have to do is you have to convert it to the standard form. What's the standard form? Y equals mx plus c. And then you can compare whatever is the coefficient of x there, that will be the gradient. Let's make y the subject. You get y equals 7 minus 4x, or you can write it like this instead, minus 4x plus 7. 5y equals this, and then y equals minus 4 over 5 times x plus 7 over 5. You've made y the subject. Your standard form was supposed to be y equals mx plus c. You compare with that. What's the gradient? The gradient is minus 4 over 5. That's the value of the gradient that we were looking for. Okay. All right. Now, what if you had a line like this? What if you had, okay. What if you had something like this? Y equals minus 4. What's the gradient of this line? Y equals minus 4. Y equals minus 4. What's the gradient of this line? What kind of a line is it? Minus 4? Is the gradient minus 4? If you were to draw this line, how would this line look like? This would be a horizontal line, right? It would be a horizontal line. Y equals something, y equals minus 4, so it should be 0, right? It's a horizontal line. Draw this. There'll be some point minus 4 here, and this line is going to be like this. It's a horizontal line. And what's the gradient of horizontal lines? The gradient of horizontal lines is 0. So this gradient is going to be 0. If you were to compare it with the standard form, y equals mx plus c, you can basically say it's y equals 0x minus 4 because there's no x here, right? If there's no x, that means the coefficient of x is 0. And now if you compare it with the standard form, it's y equals mx plus c. This is the y-intercept, minus 4. The gradient is 0. Okay, the gradient is 0. Okay, what if you have this line? X equals 3. What about this gradient? Now, this is something that you cannot convert to standard form because there's no y here. But you can think of it graphically. X equals 3. What does this line look like? It's a vertical line at the point 3. It's a vertical line there. Yeah. At the point 3, it's a vertical line like this. What's the gradient of vertical lines? We discussed this yesterday, or when we had our last class. Gradients of vertical lines are undefined. And this gradient is undefined because you end up getting a 0 in the denominator. So this is undefined. Okay, so that's how you find gradients of straight lines. You generally convert them to y equals mx plus c form, and then you can use that form to find the gradient by comparing where the coefficient of x is. Okay. All right, let's move on. Now, there's another thing that you will realize that you need to know when you start doing some questions. This is now something that you might not have done in O levels. So there are some shapes about which you need to know that what is their how are their diagonals related to each other? How are the diagonals related? Are they equal? Are the diagonals equal or not? Are the diagonals perpendicular or not? Do the diagonals meet at the midpoint or not? So some properties that you need to know about diagonals of quadrilaterals, that's what you want to talk about next. So what are quadrilaterals? First of all, quadrilaterals are four-sided figures. Any four-sided figure, that's called a quadrilateral. So basically a square is a quadrilateral, rectangle, parallelogram, trapezium, kite. All of these are examples of quadrilaterals. Four-sided figures, four vertices, four sides. That's what a quadrilateral is. So what we need to know is we need to understand how the diagonals of a number of different shapes are related, because the examiner expects us to know their properties. Properties of diagonals of quadrilaterals. Let's start with a square first of all. So for all of these quadrilaterals that I'm going to draw here, we need to know three things about these quadrilaterals. We want to basically ask this question: are the diagonals equal? So we're talking about diagonals, right? Are the diagonals equal? Do the diagonals meet at midpoints? And are the diagonals perpendicular? These are the three questions that we're going to be asking ourselves. Let's start with the square first of all. The diagonals of a square look like this. Right? These are the diagonals of a square. These diagonals are going to be equal. They're always equal. In a square, the diagonals are always equal. Why? Because these sides are all the same, right? So if you were to find this hypotenuse of this triangle, if you do it this way, or if you find this hypotenuse, they're going to be the same. The diagonals are the same. So they're equal to each other. So yes, they're equal. Do they meet at the midpoints? Yes, they meet at the midpoints as well. That's also true. Are they perpendicular? Yes, they also make a 90 degrees here, because all of these angles are bisected. In a square, the angles on the sides are 90 degrees. When you draw a diagonal, these angles are bisected. This becomes 45, this becomes 45, this becomes 45. What's the angle that's left in the middle? 90. So in a square, the diagonals are equal. Both the diagonals are equal. They meet at midpoints and they're also perpendicular. Okay. These are the properties of diagonals in a square. They're all equal. They're both equal. They're both perpendicular to each other. And they also meet at the midpoint. For a square, you can also say the diagonals are perpendicular bisectors of each other. The diagonals of a square are perpendicular bisectors of each other. So if you had A, B, C, D as the four vertices, you would say AC is the perpendicular bisector of BD and BD is the perpendicular bisector of AC. They are perpendicular bisectors of each other. Perpendicular bisector, what is that? Perpendicular bisector is a line that passes through the midpoint of something, and also is that passes through the midpoint of a line and is also perpendicular to that line. That's what a perpendicular bisector means. The diagonals of a square are perpendicular bisectors. Now we need to know about all of these properties for all of these different types of figures I'm going to draw here. So what are the properties? We have whether the diagonals are equal. Let me write all of those down now. Are the diagonals equal? Do they meet at midpoints? And are they perpendicular? These are the three questions that we're asking for all of these quadrilaterals. Okay, now what different quadrilaterals are we going to be talking about? Square, we talked about this already. Then we are going to have a rhombus. Then we would have a rectangle. And then a parallelogram. A kite. And then finally, trapezium. So we need to know about all of these different properties of these diagonals. Are these diagonals equal? Do they meet at midpoints? Are they perpendicular? Let's start with the square first of all. We talked about this before. In fact, I'll just draw this again here. And this is what a square would look like. One diagonal is this, and the other diagonal is this. The diagonals are both perpendicular, equal, and they meet at midpoints. So yes, they're equal, they meet at midpoints, and they're perpendicular. We talked about this before. What about rhombus? A rhombus would look something like this. What's a rhombus? A rhombus is a figure that has all sides equal. All the sides are equal. However, the angles are not 90. In a square, all sides are equal and the angles are also 90. These angles are all 90. In a rhombus, the angles are not 90. Okay, but the sides are all equal. Now, what about the diagonals of this shape? Are they going to be equal? Are these diagonals equal? What do you think? Yes? Are they going to be equal? Yes or no? Look at these numbers. Look at these lines. Do they look equal? Okay, let me help you think about it. Let's say you were to extend this line like this, and extend this line like this. One of these diagonals is joining these 2 points. Let's call this point A, let's call this point B. And the other diagonal is joining these 2 points. Let's call them, okay, no, we can't do it like this. Let's call this A, B, C, D. One of the diagonals is joining A and C, and the other is joining B and D. If you think about it, A and C are the closer points, right? They're both, so if you look like this, from left to right, B point is at the end, extreme left, and D point is at extreme right. And A and D are in the middle. A and C are in the middle. Distance from A to C is going to be less as compared to the distance from B to D. Or you could also think of it like this. If you make a triangle, right angle triangle, from A to C, what is that going to look like? AC is the diagonal. AC is the hypotenuse of this right angle triangle. And BD is the hypotenuse of a bigger right angle triangle. So BD is going to be longer as compared to AC. AC is the hypotenuse of a smaller triangle. Make sense? So the diagonals here are not equal. In a rhombus, the diagonals are not equal. One of them is longer than the other. Okay? However, even though they're not equal, they do meet at the midpoints. That means this point in the middle, this is the midpoint of both AC and BD. So if we call this point M, this is the midpoint of both the diagonals, AC and BD, where they meet each other. that point is the midpoint of both diagonals. So they do meet at midpoints. And this is a very important property, which is not very obvious. These diagonals are also perpendicular. In a rhombus as well, the diagonals are perpendicular. Okay. So in a rhombus, the diagonals are not equal, but they meet at midpoints and they are perpendicular. What about a rectangle? Let's look at a rectangle now. A rectangle looks like this. Now, how is a rectangle different from a square? The angles are all 90. However, in a rectangle, the sides are not equal now. In the rhombus, sides were equal, but angles were not equal. Now, angles are equal, but sides are not equal in a rectangle. Okay. Now, what about rectangle? What about the diagonals of a rectangle? The diagonals of a rectangle, they are equal. However, you can see that they do not make a 90. One of these angles is going to be bigger. One of these angles is going to be bigger, and the other is going to be smaller. So they do not make a 90 degrees. They're not perpendicular. However, they do meet at the midpoints. Okay, so this point is the midpoint of both the diagrams. Okay, then we have a parallelogram. A parallelogram looks like this. So now this is a figure in which the diagonals, the sides are not equal and the angles are also not equal. However, what's special about this is the opposite sides are still parallel to each other. Opposite sides are parallel. What about the diagonals of a parallelogram? One is going to be here and the other is going to be here, using the same reasoning that we did for a rhombus. These are not going to be equal. So the diagonals of a parallelogram are not equal. They do not make a 90 degrees as well. They're not perpendicular. However, they do meet at the midpoints. Like in rhombus, this point here is going to be the midpoint of the diagonals as well. Okay, so that's what happens in a parallelogram. What about a kite? What does a kite look like? Kite is a shape like this. Okay, so a kite would look something like this. Okay, what's special about a kite? What are the properties of a kite? Adjacent sides are equal, right? These two adjacent sides are equal and the other two are equal. That's what makes it a kite. Two adjacent sides, two pairs of sides are going to be equal. Adjacent side, two pairs of adjacent sides are going to be equal. How are the diagonals going to be like in this case? One is going to be here and the other is going to be here. Now they're clearly not equal. However, a kite as well always has perpendicular diagonals. The diagonals are always going to make a 90 degrees. What about the diagonals meeting at the midpoint? Let's name these vertices something, A, B, C, and D. They do not meet at the midpoints for both diagonals. However, let's call this something, let's call this point X. This point X is the midpoint of AC, but it's not the midpoint of BD. So this point in the middle is going to be the midpoint of one of the two diagonals. This point in the middle, point M, what should I denote it by? Let's call this N. This point N is the midpoint of AC. N is the midpoint of AC, but it's not the midpoint of BD. It's not the midpoint of BD. Make sense? So we can kind of represent it like this, yes and no. Why? Because in this case, we're saying N is the midpoint of AC, but not of BD. So it's the midpoint of one of the diagonals, but not of the other. Okay. And then finally, we have a trapezium. Trapezium, what does a trapezium look like? What's the property of trapezium? Trapezium is a figure like this that has two sides parallel. Two of the sides are parallel and the other two are not parallel. In this case, these two might be parallel and the other two are not parallel. What about a trapezium? The diagonals of a trapezium would look like this, and this. Now, they're not equal. The diagonals are not equal. They're not, they do not meet at midpoints, and they are not perpendicular. So in general, none of these conditions is met. Okay, none of these properties is true. So this is the summary of all that you need to know about the diagonals of these quadrilaterals. Okay, make sense? Now, there are some of these properties that are more important than others that are used more often. Square and rhombus, all of these properties, they are tested quite often. The diagonal, so you primarily have to focus on what is true because that's what you have to use. For a square, all of these three things are true. For a rhombus, the diagonals meet at midpoints and they are perpendicular. So this is tested a lot, that the diagonals are perpendicular for a rhombus and they're also equal. Okay, for a rectangle, it's often tested as well, yes, but that's kind of obvious. For a parallelogram, meeting at midpoints, this is also tested. So again, so basically, mostly these, mostly the ones that have a tick sign here, you need to remember that you will have to use these. Okay, yeah, so that's pretty much all of them. Let me just get rid of that. So basically, whichever properties are true, you need to remember them because you will need to use them in different places. So these are the properties that are true for these different shapes. The others are kind of easy to figure out in a particular question. This is the one that you might not remember, might not be able to figure out yourself in a question unless you remember it. The ones for rhombus, that the diagonals are perpendicular for a rhombus and the meet at midpoints. The others that are tested are often pretty obvious. For a square, it's kind of obvious. For a rectangle, these are obvious. Parallelogram, the diagonal in a parallelogram, they meet at the midpoints. That's also kind of obvious. So it's mostly the properties of rhombus that you tend to forget. So make sure that you remember them. That the diagonals of a rhombus, they are perpendicular and they also meet at midpoints. Now, let me also just write this on the side. In squares, in a square and a rhombus, the diagonals are perpendicular bisectors of each other. So this is important to remember for a square and a rhombus. In a square, and in a rhombus, the diagonals are perpendicular bisectors of each other. Okay, so that's what you need to keep in mind. All right, so you need to keep all of these properties in mind now. So make sure that you remember them, especially for rhombus. The others you can kind of figure out yourself in the question as well, or guess in the question as well. It's sometimes difficult to do that for a rhombus. Just make sure that you remember that. Okay, let's do the last thing for today then. And that is how to find equations of perpendicular bisectors. Again, that's also something that you've done in O-levels, so it's also not very new for you. Finding equations of a perpendicular bisector. In fact, the second last thing, because before this, there's another thing that I want to mention here. So we talked about the diagonals being midpoints and the diagonals being perpendicular sometimes. So there's this vector method that you will often use in some questions. So let me tell you about that as well. So sometimes what happens is, so you can actually add another page for this. So it's there as a separate page in your notes. Using a vector method to find coordinates of point. Now, what is this about? Sometimes what they do is they give you a parallelogram, another shape out of those different shapes that I showed you. So you might have a parallelogram like this. And now what they might do would be, they might do this, that they give you this point. And so this point is 2 and 3. And you have another point here, which is -1 and 0, let's say, or let's say -2, -1 and -2. This is this point here. And then you also know, for instance, the midpoint of this diagonal. Let's say you know this point. This point is M. Let's write down the coordinates of this point as well. So it's a parallelogram. And let me call these points something. Let's say this is point A and this is point B. I actually forgot what I wrote there. It was 2, 3, and -1, -2. Okay. A, 2, 3, and B was -1, -2. And it's a parallelogram now. Let's suppose we know the midpoint here. This is point M of this diagonal, and let's say that midpoint is 4 and 0.5. Okay, what we want to do is we want to find these 2 points, points C and D. We want to find the points C and D of this parallelogram. The vertices C and D. So what are the coordinates of C and D? Find the coordinates of C and D. That's what you want to find out. Now, one idea could be that you use the midpoint formula, right? if you, for example, if you start with with D first of all, you could find D using the midpoint formula that you could say the midpoint of BD is M, right? Midpoint of BD is M. Let's consider the coordinates of D to be X and Y, or let's call them A and B. The coordinates of D, let's call them AB. How do you find the midpoint of BD? X1 plus X2 over 2, Y1 plus Y2 over 2. So you could say minus 1 plus A over 2, right? Minus 1 plus A divided by 2. And then minus 2 plus B divided by 2. This is how you find the midpoint of BD. That should be the same as M. The point M is 4 and 0.5. This is one idea that you use the midpoint formula and you say that this is minus 1 plus A over 2. This is the X coordinate of the midpoint that you have found. And they have given this X coordinate to be 4. And then the Y coordinate given here is Y coordinate that you have found is minus 2 plus B over 2. And they have given the Y coordinate to be 0.5. So one possibility could be that you could make two equations like this, minus 1 plus A over 2, that equals 4, and minus 2 plus B divided by 2, that equals 0.5. You solve the first equation, that gives you minus 1 plus A equal to 8, and the value of A turns out to be 9. And you solve the second equation, that gives you minus 2 plus B equals 2 into 0.5, that's 1, and the value of B turns out to be 3. That is one possibility. That's one possibility, that you use the midpoint formula to find these coordinates. That gives you the coordinates of D, which are 9 and 3. Okay, that's one idea. Now, another possibility could be okay, so this is one idea. Another possibility could be like this. Let's consider the same situation again. And we could do it in a much quicker way as well. How would we do that? Let's consider the same question again. What we have to do is we have to find the coordinates of the point D. You could use something that we call a vector method for this. How would that work? We want to find the coordinates of D first of all, let's say. Okay. M is the midpoint of B and D. M is the midpoint of B and D, right? We can say M is halfway from B to D, right? M is halfway from B to D. What we want to do is we want to find the coordinates of the point D. The coordinates of B are minus 1 and minus 2. How much do we have to go to the right? How much do we have to go to the right? To go from point B to point M, we have to go from minus 1 to 4. How many units do we have to go to the right to get to the point B? Minus 1 to 4, that's 5 units. So in order to go from point B to M, we have to go 5 units to the right. From B to M, we have to go 5 units to the right. Now, in order to go from M to D, we can just go 5 more units, and that will make us reach this point D. So minus 1 to 4, that's 5 units. You add 5 more to 4, that gives you 9 here. And similarly, you do the same thing vertically. How much do you have to add to minus 2 to get to 0.5? Minus 2 to 0.5, you have to add 2.5. You have to go from minus 2 to 0.5, right? You have to go 2.5 units up. Now, in order to go from M to D, you go 2.5 more units. So 0.5 plus 2.5, that gives you 3. So the coordinates of D turn out to be 9 and 3. So you could kind of do it in your head as well, or with minimal working. If you wanted to show this working, which I recommend that you do, that will save you from careless errors. A way to show this working is like this. You say B point is minus 1 and minus 2. And then the point M, which is the midpoint of B and D, that is 4 and 0.5. And you want to find the coordinates of the point D. And you represent it like this. Okay, how many units do you have to go from -1 to 4? You have to go 5 units. You have to add 5 to it. And then you just add 5 more to that to get 9 here. Similarly, how much do you have to add to -2 to get to 0.5? You have to add 2.5. You add 2.5 more here. That gives you 0.5 plus 2.5, that's 3. So the coordinates of D therefore are 9 and 3. This is called the vector method because we're kind of using vectors that, okay, this is the X component, this is the Y component, this is how much you have to go in the X direction, this is how much you have to go in the Y direction, right? So it's called the vector method, but you can just represent it like this, and you can find the coordinates of D much quicker like this. And now you can use that same idea for the point C as well. If you had to find the point C now, AB line is parallel to the DC line, right? AB and DC are parallel, just like AD and DC are parallel. You know the point A and you know the point B. And now you know the point D as well, right? What you can do is you can say the number of units that you have to go from in order to go from A to B for in X and Y directions, you will do the same thing to go from D to C and you will reach the point C. Okay. So let me just write that down. That will help you understand it better. In order to go from A to C, what do we have to do? To B, in fact, the point A is 2 and 3, and point B is -1 and -2. How do we go from point 2 to -1? How do we go from 2 to -1? We have to subtract 3. We have to do -3. And how do we go from 3 to -2? We have to subtract 5. We have to do -5. And now, how do we go from point D to point C? We do the same thing for that. The coordinates of D are 9 and 3 now, right? How do we reach point C from there? We do the same operations here. To the X coordinate, we say, let's subtract 3 from the X coordinate. That gives you 6. And subtract 5 from the Y coordinate, that gives you -2. And these are going to be the coordinates of the point C. And you get those, you get that point C directly like this. Make sense? And this will be quicker than any other method that you can think of. You can just do it in a single step like this. You find the point C directly like this. That's 6 and -2. Another idea here could be, you did not have the point D. If you wanted to find point C directly, then you could use that property. The midpoints of the diagonals of the parallelogram, the diagonals of the parallelogram, they meet at the same point. So if M is the midpoint of BD, then M should also be the midpoint of this other diagonal. So you could use that as well, that, okay, in order to go from A to M, you have to go this many units to the right, this many units down, and you do the same thing from M to C. Just like we did for D earlier, we could do the same thing for C as well. If we started from A and made this diagonal, that could be another idea as well. Or you could do it like this. Since you have D already now, you can just use AB and DC in this case. And that gives you that point C that you were looking for. So we have D and you have C here. Any problem with this? Any questions? No? No problems?
No problem, sir.
Okay, one last thing, and then we'll end. Finding equation of a perpendicular bisector, because after this now, you should be able to attempt almost the complete worksheet. It's just one type of problem that we haven't discussed it, and that's finding angle between two lines, and also area of some shapes using their coordinates. We'll talk about that in the next class. But for now, let's just end with this. How to find equation of the perpendicular bisector of 2 points. Let's say we have 2 points like this. We have a point A here, and we have a point B here. The coordinates of the point A are, let's say, -2 and 5. We have another point B that has coordinates 6 and 8. We want to find the equation of the perpendicular bisector. Find the equation of the perpendicular bisector of AB. Okay, we have the coordinates given on the diagram. Okay, we want to find the equation of the perpendicular bisector. Now, what is a perpendicular bisector? What is a perpendicular bisector? Perpendicular means the angle that this line would make with AB is going to be 90 degrees. Perpendicular means the angle is 90 degrees with this line AB. And bisector means it cuts that line at midpoint. And that's what bisecting means. It cuts at the midpoint. It cuts at midpoint. Perpendicular bisector of AB, that means find the equation of a line that cuts AB at the midpoint and is perpendicular to AB. Now, what is the perpendicular bisector going to look like? It's going to be something like this. Okay. This is the perpendicular, and it passes to this point M, which is the midpoint of A and B. How do you find the equation of this line? You need two things to find the equation of any line. It's a straight line, right? Perpendicular bisector is also a straight line. In order to find the equation of any straight line, you need two things. One, you need a point on the line, and number two, you need the gradient of the line. How can you find a point lying on this line? This midpoint lies on the line, so you can find the midpoint of A and B. Okay, let's start with that. How do you find the midpoint of AB? M is the midpoint of AB. M is the midpoint of AB. Let's use the midpoint formula and figure out what M's coordinates are going to be. -2 plus 6 divided by 2 and 5 plus 8 divided by 2. This is the midpoint of AB. These are the coordinates of the point M. Simplify this and see what this turns out to be. 4/2, that's 2. And 13/2, that's 6.5. Just write it as 13/2. These are the coordinates of the point M. Okay. That's the first thing. We have a point that lies on the line now. We also want the gradient of the perpendicular bisector. Okay. How do you find the gradient of the perpendicular bisector? What you can do is you can find the gradient of the line AB. Right? Let's find that. Gradient of the line AB. How do you find that? Y2 minus Y1 or X2 minus X1? 8 minus 5. That's 8 minus 5 divided by X2 minus X1. That's 6 minus -2. That's 6 plus 2. What do you get from this? You get 3/8. That's the gradient. The gradient of this line is 3/8. Now, this is the gradient of AB. What about the gradient of the perpendicular bisector? Gradient of the perpendicular of AB. This is the sign that we use for perpendicular sometimes. It's inverted T, that means perpendicular. Gradient of perpendicular of AB, that's going to be negative reciprocal of this. That's -8/3. So now we have a point on the perpendicular bisector and we have the gradient of the perpendicular bisector. We can use these two things to write down the equation of the line. Okay. So what's the point? The point is 2 and 13/2. That's the point. And we have the gradient. The gradient is -8/3. We can write down the equation of the line using y minus y1 equals m into x minus x1. This is x1, this is y1, this is m. Just input values here. You get y minus 13/2 divided equal to minus 8 over 3 into x minus 2. And that's the equation of the line that you were looking for. You can just leave it like this and that's going to be acceptable. That's the equation of the perpendicular bisector. If you wanted to simplify this, you can do that. You can say this is y minus 13 over 2. That equals minus 8 over 3x plus 16 over 3. You take this constant to the other side. That will make it minus 8 over 3x plus 16 over 3 plus 13 over 2. You can see whatever that turns out to be. 32 plus 39, that's going to be 71. I think it's going to be 71 over 6, right? That's the equation that you get. So you can write it in any one of these two forms. That's going to be acceptable. So how do you find the equation of a perpendicular bisector? Perpendicular bisector means it's a line that is at an angle of 90 degrees to that original line. Bisector means it cuts that line at the midpoint. In order to find the equation of a line, you need two things: a point and gradient. Point you can find using the midpoint formula, because that midpoint lies on the perpendicular bisector. Gradient of AB you can find by using the coordinates of those 2 points, and then you can just take negative reciprocal of that to find the gradient of the perpendicular bisector. Once you have the gradient and a point on the line, which was 2 and 13 over 2 in this case, you put those two things in this equation, in this form, y minus y1 equals m into x minus x1, and that will give you the equation of that perpendicular bisector. Rizal is asking, can we always leave it like this? Well, no, because sometimes they do ask you in the questions that you want to write your answer in a particular, that you need to write your answer in a particular form. So they might ask you to write down the equation in this form, y equals mx plus c. In that case, you would convert it to this form. Sometimes they also ask you to write down the equation in this form, ax plus by equals c. This is another form that they ask you to write down your equation in. If you had to do that, you would write it something like this. You take the LCM. LCM is 6. Multiply the whole equation by 6. That gives you 6y equals minus 16x plus 71. And another form could be 16x plus 6y equals 71. This is another form. So if they ask you to write in this form, ax plus by equals c, you would write it like this. If they ask you to write in y equals mx plus c form, you would write it like this. If they don't specify anything, which is going to be the case in most cases, or maybe not most, you can say 50% of cases at least, they would not ask you to write your answer in a particular form. When that happens, you can leave it like this. But if they do ask you to convert it to a particular form, then you have to do it. It could either be y equals mx plus c form, or it could be ax plus by equals c. That means x and y terms on one side and constant on the other side. Make sense?
Yes, sir.
So now you should be able to do most questions from the worksheet, almost the whole worksheet. In the next class, we will be discussing your problems from the worksheet, and then we will spend a class on discussing 2 more concepts. We have 2 things left. One, how to find angle between 2 lines, how to find angle between a line and x-axis as well. And in addition to that, how to find areas of diagrams using their coordinates. So if you have a triangle and we only know the coordinates of that triangle, of the vertices of that triangle, how to find the area of that triangle, or maybe a quadrilateral, how do you find those areas? That's what we want to still do. But we will spend the next class doing some practice questions, and then in the class after that, we will be doing those concepts that I'm talking about. All right, so that's it for today. If you have any quick questions, you can let me know. Otherwise, I'm going to end this class here. Any problems, anyone? No problems? Okay, all right. I'll see you again in the next class then. Allah Hafiz. Please make sure to attempt the questions from the worksheet. You have some questions assigned. You can start working on them. We will be discussing them in the next class. All right. Allah Hafiz.